Hi dear students, in the last video we derived the expression for electric potential due to point charge, and the final expression we got, that is V is equals to 1 by 4 pi epsilon naught Q by R, isn't it, where Q is a source charge and R is that distance. Yes, now we have to derive the expression for electric potential due to system of charges. So system of charges means if we have more than two charges, we can call it as a system of charges. So here we are going to consider many charges, that is, let us have n number of charges. As we are observing in the diagram, see, here we have the first charge q1, here we have the second charge q2, here we have the third charge, the fourth charge. Like this we can have n number of charges. So with these n number of charges, we have to find the potential at a common point, that is P. As we all know that potential depends on the distance, hence we are considering the distance of that point P from all the charges, that is R1P is the distance of point P from first charge, R2P is the distance of point P from second charge, R3P. In the same way, we are going to have RNP is the distance of the common point P, where we have to find the potential due to all the charges, that is due to system of charges. Yes, so in order to find electric potential due to system of charges, we have to make use of principle of superposition. The statement of that principle of superposition is that, observe clearly there, when a system of charges is present. So now we have system of charges with us. The net electric potential at a point. So the total electric potential, the net electric potential at a point, here we are considering that point as P, is equal to algebraic sum of potentials at that point due to individual charges. That means here we have to find the potential at P due to the first charge, the potential at P due to second charge, the potential at P due to third charge, and so on, and we have to get the algebraic sum of all the potentials due to the individual charges. That is going to give the expression for electric potential due to system of charges. So observe the diagram carefully, and we have the common point P with respect to the different charges, and we have the respective distances. So now consider a system of n charges q1, q2 and so on qn lying at a distances r1p, r2p, so on rnp respectively from a common point P as shown in a figure. Then we are making use of the superposition principle. So the total potential at P, what we are considering now, the total potential at P. So observe this expression. V is equals to V1 plus V2 plus so on plus Vn, where what we can call that V1, that is the potential at point P due to first charge. Then what about V2? Yes, that's the potential at point P due to the second charge, and so on Vn, that is a potential at point P due to the nth charge. So here we are making use of that superposition principle, and as we already know that expression for potential due to point charge, so here V1 is equals to 1 by 4 pi epsilon naught Q1 divided by R1P, where Q1 is the first charge and point P is at a distance of R1P from that charge. Similarly, we have the expression, that is V2 is equals to 1 by 4 pi epsilon naught Q2 by R2P, that is potential due to second charge, and so on. We can have the expression for potential due to nth charge, that is, what was that? Vn is equals to 1 by 4 pi epsilon naught Qn divided by Rnp. So with this V1, V2, V3, we have to substitute that in this expression where the total potential at point P V is equals to V1 plus V2 plus 1 plus Vn, and we have the expressions for V1, V2 and so on. So we have to substitute that. Yes, here we are going to substitute that V is equals to, instead of V1 we can write as 1 by 4 pi epsilon naught Q1 by R1P plus, instead of V2 we have substituted 1 by 4 pi epsilon naught Q2 by R2P plus 1 plus 1 by 4 pi epsilon naught Qn divided by Rnp. So which is a common factor we have? In all the terms we have that 1 by 4 pi epsilon naught as a common factor. So by taking that as a common factor, we have that expression V is equals to 1 by 4 pi epsilon naught of Q1 by R1P plus Q2 by R2P plus so on plus Qn by Rnp. So by making use of the summation, we can write the final expression, that is V, total potential at a given point due to system of charges, is equals to 1 by 4 pi epsilon naught summation, where I is equals to, so here we have that potential due to first and n number of charges, right? That I varies from 1 to n Q I divided by R I P. This is the final expression. V is equals to 1 by 4 pi epsilon naught summation I is equals to 1 to n Q I divided by R I P.